Hello and welcome to this video. So in this video we will look at the implementation of breadth first search. So as we discussed in previous video, the algorithm of breadth first search. If you're not familiar with the implementation of or algorithm of breadth first search, you should go and watch my previous video on how to traverse a graph using breadth first search. Plus, if you are new to graph, then you will have to go back 3-4 videos in the playlist and you start from the beginning where we have discussed the transitive closure and Warsaw algorithms and how breadth first search actually works. So this is a straightforward implementation. We have kept the implementation simple. As always, I have defined 3 files. First is the header, second is the driver program main.c, and third is the core logic of the algorithm. So the header file includes a queue because, as you remember, our queue will keep the reached elements. So we will enqueue into the reached element and we will dequeue from it one by one till the queue becomes empty. So this is an array based queue. You can always choose to implement using linked list based queues, then your this limitation of max size will be removed. I've kept it simple. So 100 nodes is what I will be encountering. But suppose you are doing a deep graph of, for example, let's say binary search tree, then 100 will be exhausted at 7th level. 7th level means, or 6th level rather. So 6th level would be total number of elements including all the elements of 6th level of a binary tree would be 2 to the power 7 minus 1, which is larger than 100. So in case your graph size is big, you might want to use a linked list based queues rather than array based queues, because the size of a graph it can increase exponentially very quickly. So for the simplicity, we have chosen this array-based queue. There is no other reason. And there are standard functions like create queue, enqueue, dequeue, display. I'm not sure if I have implemented display. Is empty front. So this is what will contain the front and rear. So these two will point at front and rear. And similarly, we have created a node whose vertex is integer for simplicity. A node can point to another node. So we have a create node and we have graph. Graph will contain an num vertices, number of vertices. We have an adjacency list. So as you remember from previous discussion, the adjacency list will be pointing to um, a linked list. So this has to be list of lists. We have the visited, which will be our visited array, where we will store the visited nodes of the graph. There are simple 3 functions: create graph, we have join to join 2 nodes, and BFS to perform the actual BFS. So the crux of this entire program is this function. This is the core functionality. So main is simple. We have create graph. We have 0 to 1, 0 to 2. We are creating a graph of 6 nodes. So we have 0 to 1, 1 to 2, 0 to 2, 1 to 2, 1 to 3, 2 to 4, 3 to 4. So let's say analyze once whether we can explore the full graph. We can go from 0 to 1 or 0 to 2. Then from 1, we can go to 1 to 2 and 1 to 3. Then from 2 to 2, we can go to 4. Okay. And from 3 also, we can go to 4. So we see that from 0, we can explore all the nodes. And we have the starting node. We start from 0 and we explore the entire node. Okay. Now we look at the actual logic. We won't look at the queue implementation. Queue implementation is here. It is pretty straightforward implementation of array-based queue. So we will look at the graph-based functions. So first is create graph. We receive int of vertices. We allocate for the size of graph, and then we set the number of vertices to however number of vertices you might want to pass. We allocate for adjacency list and we allocate for visited. Now for number of vertices, we set the adjacency list to null and visited to 0. So this is the create graph function. For join, what we do is we create the node. Okay, we should first look at the node. So for creating the node, we allocate memory for node. We set the int value vertex to the supplied value we set next to null, and then we return this node. Now we look at join. So what join does is it creates a node for the destination and it receives the source node also. Now you see it, what it does is it sets the temp next to a graph adjacency list src. So src is assigned to temp next, okay, and then adjacency list src is assigned the value of temp. Because of this reason, what will happen is when we traverse here 0 to 1, 0 to 2, and when we dequeue, then 2 will be traversed first because of this implementation of join. Okay, so be careful when you're trying to follow the logic. From here you would think that if we go from 0, then 1 should be visited first in best first search, but this adjacency list is not created that way. So 2 will be visited first followed by 1, and similarly from 1 we will visit 3 first. 2 is already visited in any case. No, 2 is not visited yet. From 1 we will visit 3 first, okay, and then 2 is visited because 0 points to 2, so 2 would be visited, and then we will visit 2. We will not visit 2. I'm confused. Hang on. First we visit 0. So 0 gives 2 edges, 1 and 2. So then 1 will not be visited. First it will visit 2. Then it will put 0 in the reached element 4. But after 2, it will go to 1. Okay. So when 1 will be explored, it will see 2 children. So out of those, 3 will be visited first, then 2 will be visited. But 2 is already visited from 0. So the graph will print 0, 2, 1, 3, and then 4. That's what it should print. So if you are confused that why it is not printing in order, the reason is this function. Okay. So we have covered create graph, create node. Now we'll look at our best first search. So it would be best if you open the previous video and you look at the slide which I have created for traversal. So first we create the queue. We set the start vertices index to 1. That is our visited. Then we enqueue that element into the queue and we print a message best first traversal starting from vertex D. So for our case it would be 0. So it will print 0. Now the queue is not empty in the while list. So it will dequeue queue. We dequeue queue and we print it. This printing can be done after this also. This printing cannot be done after this because after this front, after dequeuing, front won't be available. So we print it first and then we dequeue. Then we look at the adjacency list. Okay. And then we traverse the entire adjacency list of that particular vertex. So what happens here, if you look at this, 0 will have 2 elements in the adjacency list, 2 and 1. 2 will be at the beginning followed by 1. So it will iterate here and enqueue 2 followed by 1 in the queue. So what it does is it takes an adjacent vertex and takes the temp's vertex to adjacent vertex. Now if visited of this vertex is 0, then we mark it visited and enqueue it in the queue. Otherwise we move on to next element. So here what will happen is it will look at temp, that is adjacency list of the first element would be 2. So temp's vertex would be 2, but 2 is not visited in the graph. So it will mark 2 as the visited vertex and enqueue q. So q here is 0. So it will enqueue 2 in the adjacent vertex, that is this. In the queue adjacent vertex 2 would be queued here. So 2 is queued. After that, it will move on to next element in the adjacency list. It will find 1 in the while loop. It will find 1. Okay. So now our adjacent vertex would be 1. So 1 is not visited. It will mark it 1 and then move on. And then this adjacency list is exhausted. Okay. So it will go and it will see if the queue is empty, but the queue is not empty. So it will print 2 now, because in the queue it will move. After dequeuing 0, we have 2, 1 in the queue. So it will print 2 and then it will look at 2. All right. Then for 2, it will find there is an element 4. So it will enqueue that element 4. So that's why it will print 0, 2, 4, 1, 3. Okay. That's what it should print. So let's see this in action. So I have already compiled this program and I know the result. So in case you are wondering, so as expected, it prints 0, 2, 1, 4, 3. Okay. So this is basically all about this function, that is BFS. What is a bad thing about BFS is that it stores a lot of data. Okay. And that is twice. One is your visited array and another is your this queue maintenance. So queue and visited can be problematic when your graph is big. Okay. This problem is sorted by the depth first search. Breadth first search is very heavy on memory, even when using adjacency lists. So we will see how depth first search solves our problem of memory consumption. But then there are two properties associated with breadth first search, and both are very desirable. One is that it is capable of exploring the entire graph. Second is that it is optimal. It will always give you the optimal search of all the paths. When I'm talking about optimal, it means in the sense of cost. Okay, we have not yet covered the weighted graphs and its traversal, but in a weighted graph, if you have a cost function, then it will always give you the path with the least cost. Depth first search does not do that. But again, in practical terms, if you want to explore a large graph, then you just can't afford breadth first search, because memory consumption would be very high. So for those cases, we use depth first search. So in the next video, I will cover the algorithm and the implementation at the same time for depth first search. Note that depth first search comes in two versions. One is an iterative version and second is a recursive version. So we will see both of them and most probably two videos. And in the second video, from now on, we will compare the graphs and complexity and all that, and all the properties, what is desirable and what is good, what is bad about these algorithms. So I hope you have found this video useful and informative. If so, please subscribe to the channel, like the video, share it to social media, and make use of comment box to speak your mind, because I would like to talk with you guys, to communicate with you guys, to know you better and to understand from you that what other topics you want videos on, like the popular stuff or for required for your job and things like that. It would be good to have a chat with you guys. The second advantage is that when you subscribe and like, YouTube algorithm basically shows this video at many places in suggestion or search boxes, so the reach of video grows. So these are the two main reasons, and the third and most important reason is that when you like, subscribe, it motivates me to make more such videos. So please do this, and thanks a lot for watching. Happy programming.